So this is the second video we've got on working out chemical formulae. It's part of a topic which we call stoichiometry, which really is about the relationship between the amounts of substances taking part in a reaction or forming a compound. And here, really, we're looking at forming a compound. Now, I've read in syllabuses that we need to state the formulas of the elements. Easy. Periodic table. And compounds in the syllabus. That's the challenge. Now, I looked in the previous video about how to work out the chemical formula of a substance that contains two elements, just looking at the groups that the elements come from. That I call part one. Part two would be doing the same thing when one of the elements, almost always a transition element, was involved, because there's no group involved there. Step three now is looking at what we call polyatomic ions, ions that contain more than one atom. For example, calcium sulfate, iron 2 nitrate ions a transition element, and so I need to know the combining power, the valency. I put water and carbohydrate down there just to show something. Now, we know from the past, IDE means full stop, period. That's it. If I talk about sodium chloride, that compound contains sodium and chlorine, and that's it. There's another code aside from IDE. ATE means oxygen is also present. So we see a name ending in ATE, it tells us that a group of atoms are sticking together. First example, sodium sulfate. When I look at that, I'm thinking three things. I'm thinking it contains sodium from the name, sulfur from the name, and because ATE equals oxygen, oxygen is also there. The sulfur and the oxygen would be present as a sulfate group. Now, if I look at calcium sulfate again, I'm seeing that that compound contains calcium, Ca, sulfur, and because of the ATE, it contains oxygen. Iron 2 nitrate would contain iron with a charge 2+. The NITR indicates nitrogen. I see it there in parenthesis. ATE equals oxygen. Got it. So for now, we're just looking at the name and realizing the elements that are contained. Water, a little bit different. Water has got a common name. ATE, though, if you look at it, is the middle part of the water molecule, H2O. And this is also useful in bio. In bio, we have to realize that carbohydrates are made of three elements: carbon, hydrogen, and oxygen. If you're familiar with the rule for ATE, it's easy. Carbo, carbon. Hydra, hydrogen. ATE means oxygen. Now, what we're not looking at here really is not working out the actual formula of compounds just yet. We're looking at just identifying what elements are present there. If I know that I contain different ions, in the first example, calcium and sulfate, then all I've got to do is to realize that these must always balance. Now, my groups of atoms either come from an acid or from water or the chemical ammonia. And hydrogen is always lost when such groups are made. One example, that's ammonia. The number of hydrogen ions lost or gained from the parent compound tells us the charge on the group that's left behind. Hydrogen ions always have a charge of +1. Now, if we look at the formula of the parent compound, my example below, sulfuric acid, H2SO4. If that one is not familiar with you just yet, it will be. Comes up so many times. But if we look at the formula of the parent compound, we can work out the name of an ion that it forms. Sulfuric acid. If one hydrogen ion is lost, what's left? I've got my hydrogen ion as H plus on the right side, the product side of the equation. Everything else that was on the left side, HSO4, is also present. Now, if hydrogen came off as H plus, what's left behind must have become negative. Charge has to balance. The hydrogen sulfate must have a charge of -1. One hydrogen was lost from sulfuric acid, leaving HSO4 behind. Charge must be -1 to give an overall charge of 0, which is the charge on the sulfuric acid to begin with. If two hydrogen ions are lost, a sulfate is formed. No mention of hydrogen anymore because it's not present in the sulfate group. There's my sulfate group. And if two hydrogen ions were lost as H+, from neutral H2SO4, then what's left must have a charge of -2. My sulfate group has a charge of -2. Now, for all of my polyatomic ions, I've got them here. We've looked at sulfuric acid, H2SO4. It can lose one hydrogen, it can lose both. It's H2SO4. As we've seen, one hydrogen lost, what's left is a hydrogen and SO4 sulfate. So one hydrogen lost, HSO4 is left. Hydrogen sulfate must have a charge of negative. Both hydrogens lost, sulfate. And if both hydrogens are lost, that's 2H+, sulfate must have a charge of -2. Another common one, not nearly as common, carbonate, hydrogen carbonate, coming from carbonic acid. Rarely mentioned in the syllabus, but just to say, carbonic acid is rain. It forms when water, falling through the atmosphere, dissolves carbon dioxide. And if I add up everything in H2O and CO2, I get H2CO3. Now that's useful because I can use it to figure that if one hydrogen is lost, I will get HCO3 left over. That ion is called a hydrogen carbonate. One hydrogen was lost, the charge on hydrogen carbonate must be negative. If both hydrogens were lost as hydrogen ions, what's left is CO3, carbonate. Two hydrogen ions lost, 2H+, what's left behind must have a double negative charge. H2CO3 would begin with no charge. If two hydrogen ions came off as H+, what's left behind is CO3, 2-. If nitrate comes from nitric acid is HNO3. If one hydrogen ion is lost, then what's left is NO3 as a nitrate. One hydrogen ion lost as H+, nitrate ion must have a charge of NO3-. Even starting with water, no need for my 8 rule here. What's left is an oxygen and a hydrogen. One hydrogen lost, one remains. We call that the hydroxide. OH, one H+ lost. The OH must have a charge of -1. Start off as neutral water, H2O. H+ comes off as a hydrogen ion. What's left must be OH-. Charge always balances. Finally, ammonia. This is the unusual one. NH3 can actually gain a hydrogen ion. And this is the opposite way around. If I gain a hydrogen ion, that's gaining a H+. NH3 must become NH4+. And we call that the ammonium. IUM because it's making a positive ion. Metals, potassium, sodium, lithium, calcium, magnesium, make positive ions. This is a positive ion, so ammonium. Now, I've taken this from my first discussion of chemical formula. Positive and negative charges have to balance in any compound. Formula of the compounds is always found by balancing charges. So, for example, my first one, sodium sulfate. I could look at the periodic table and see sodium is Na+. I could remember sulfate coming from SO42-, coming from sulfuric acid, being SO42-, because that's what's left when two hydrogen ions are lost. Combining those together to give no charge, Na2SO4. Magnesium hydroxide, Mg2+, group 2 in the periodic table, OH- coming from water. I need 2 of the OH- to balance the Mg2+. And that would then give me Mg, note the use of parenthesis, OH twice. Aluminium nitrate, aluminium group 3, Al3+. Group 3, 3 electrons in the outside shell. They had to be lost when the ion was formed, Al3+. Nitrate, one of my polyatomic ions from nitric acid, NO3 negative. I just balance the charge. 1 aluminium 3 plus requires 3 nitrates to make AlNO3 3 times. Aluminium sulfate, okay, aluminium 3 plus again. Sulfate from sulfuric acid, SO4 2 minus. Sulfuric acid being H2SO4, lost 2 hydrogen ions to make SO4 negative 2, and I get the negative charge because 2 H plus ions were formed. Going back a little bit, the ion with the positive charge is always named first, negative ion named second. Sodium sulfate called that way because the sodium ion is positive, the sulfate negative. Now for this one, what I've done is to give the formula of the ions. The more you use these formula of ions, the more familiar you get with them. My compound, aluminium 3 plus, nitrate NO3 negative 1, 3 nitrates needed for the aluminium charge to be cancelled out. And there we have it. Parenthesis again, because I've got the whole NO3 group 3 times. Ammonium hydroxide, NH4 plus for ammonium, OH minus for the hydroxide, NH4OH. Let me pause before the next one, give you time to think of it. Pause me, I'll continue. Potassium sulfate. Potassium group 1, K+. Sulfate, polyatomic ion from sulfuric acid, H2SO4, 2 hydrogen ions lost, SO4 2 minus. I need 2 of my K pluses to balance the SO4 2 minus. There's my formula, K2, SO4. No need for parenthesis here. The sulfate group as a group is only there once. Potassium hydrogen sulfate. Now, hydrogen is named. Sulfuric acid, H2SO4, lost only 1 hydrogen as a hydrogen ion in making HSO4. 1 hydrogen ion lost, so the charge is only negative 1. There is my formula. Now I've put magnesium sulfide in here. This is me being a little bit wicked. You notice the ending of the name, IDE. That's the first rule we came across when it comes to naming compounds. IDE means period, full stop, nothing else there but magnesium, group 2, 2 plus, and sulfide from sulfur, group 6, S2 minus. So I'm not dealing with a polyatomic there. The name should give it away. Ammonium, from ammonia. The only substance that gains hydrogen ions for us. Sulfate, again from sulfuric acid, SO4 2-. I must have 2 of the NH4s to balance the SO4. Got to be careful here, because there's 2 of that group, NH4. I now need parenthesis. Now, tiny little point. ITE, not ATE. It just means 1 less oxygen than we have with 8. So if sulfate is SO4 2-, sulfite is SO3 2-. If nitrate is NO3-, nitrite is NO2-. And everything else stays the same. Sodium sulfate is Na2SO4. Sodium sulfite contains the sulfite ion, 1 less oxygen than sulfate, Na2SO3. Magnesium sulfate, MgSO4. Magnesium sulfite, the ite ion, 1 less oxygen than there would be in sulfate. We have that up here at the top, MgSO3. Potassium nitrate would be KNO3. Potassium group 1 plus 1. Nitrate, NO3 from nitric acid, 1 hydrogen lost from HNO3, NO3 - 1. The only difference with the nitrite, 1 oxygen less, KNO2. Potassium nitrate, calcium group 2, will combine with the NO3-, calcium group 2, Ca2 plus, NO3-1. I need 2 of the NO3s. I need my parenthesis. Calcium nitrite, exactly the same logic, only now I have the nitrite ion, NO2. 1 less oxygen than there is with nitrate, NO3. Moving on a little bit. It's unusual, but you could be asked to work out the formula from a diagram. Below I've got a diagram of sodium ions, Na+, and chloride ions, Cl-. Chloride highlighted to make it easier to pick out. I'm not going to bother going through counting. I can see there's roughly the same amount of both. I will have 1 Na+ for every Cl-, formula NaCl. A little bit harder to spot, but if I had a diagram like that one, if I'm told in the beginning we had magnesium chloride, Mg, Cl2. Chloride in blue, as we have here, red for magnesium. It's about twice as many blue as red. MgCl2 would then be my formula. One more little new thing, and it's not difficult. In organic chemistry, we're looking at the chemistry of carbon. Carbon always makes 4 bonds. It's in group 4, 4 electrons to be gained to get a full shell of 8. 4 covalent bonds will be made. We just count the number of everything there. In my first example with the double bond between the carbons, 2 carbons, 4 hydrogens. Formula C2H4. Next example, I see 4 carbons, 4 hydrogens above, 4 below, that's 8, 1 on either end, that's 10, C4H10, done. Next one, 2 carbons, 1, 2, 3, 4, 5 hydrogens, C2H5, and an OH group on the end. Now you could be forgiven for saying C2H6O, and that would be all right, unless you were told to treat the OH as a group, as one thing. Then we leave it as a group at the end of the name. Down here, 1, 2, 3 carbons. Interesting. I've got carbon making a triple bond with another carbon atom. Why not? C3, done. H4, done. And my last one. If I count them, there are 10 carbon atoms, 10 hydrogens above, 10 hydrogens below, that's 20. Add 2 with the 2 at the ends, that's 22. So just by looking at the structure of that covalent compound, I can get the chemical formula. I'll finish with this. Simply because I think the more you get familiar with these, the easier it gets. My parent compounds, I give you 5. Sulfuric acid, H2SO4. It's all about losing hydrogen ions, apart from the last example where one is gained. Sulfuric acid, I can lose 1 hydrogen, in which case what's left is HSO4. What's the charge? Well, 1 hydrogen ion was lost, H plus, the HSO4 must be minus. I can lose both hydrogens. Now what's left is sulfate, SO4. 2 hydrogens were lost from my original H2SO4, charge SO4 negative 2. Carbonic acid H2CO3, which I always remember, comes from rain, carbon dioxide in the atmosphere, dissolving in water, falling as very dilute carbonic acid. H2CO3, 1 hydrogen ion can be lost. There's my HCO3, 1 remains. Charge negative 1 is 1 hydrogen lost. 1 H plus ion lost. Carbonate, both hydrogen ions lost, that's 2 H pluses. Carbonate must be CO3 negative 2. Nitrate, only one option. Only 1 hydrogen ion to be lost. If HNO3 loses its hydrogen ion, then what's left but NO3? 1 H plus lost, gotta be NO3 minus. Hydroxide, I think of as coming from water. H2O. Hydroxide kind of tells you there's oxygen and hydrogen still there. So 1 hydrogen lost. Formula OH. If 1 H plus is lost, it's got to be OH minus. Lastly, the unusual one. Compound ammonia is the only one for us that can gain a hydrogen ion. And when it gains one as H plus, the NH3, having gained that hydrogen ion, becomes NH4 plus, ammonium. And that's it. That's the second and final video on working out chemical formula. My next video will be on equations and how to balance.